Hi and welcome to Math Pre-Calculus 20, example 1b from section 3.1. We're looking at vertex form of a quadratic. Okay, so for this one, it's already in vertex form here, so we're ready to start. I'm going to list my a, p, and q. So my a is -1/4. My p is, remember it's not -4, it's 4 because it's the opposite sign of what we see here. And q is +1, so it's the same sign. Okay, now looking at what this information tells me. Alright, this -1/4 tells me that it opens down, and it also tells me that it's wider. Right, the closer we get to 0, the wider we get. So this one here is pretty wide overall. Okay, other things, the p and q, right, that is our vertex, right? So our vertex is always p and q. So for this, our vertex is 4, 1. And the next thing then, our axis of symmetry. Our axis of symmetry, right, is a vertical line that goes through the vertex. And so therefore, it's x equals 4. It's always x equals p. So whatever our p is, that's our axis of symmetry. Okay, so I'm going to take some of this information and put it onto my graph. So I've got my x-axis, my y-axis. Okay, we've got a vertex of 4, 1, so I'm going to label a few of these. Okay, so the vertex is here. I'm going to put that so it's 4, 1. I've got my axis of symmetry, right, which is right through there at x equals 4. And it's opening down and it's pretty wide. Okay, so in order to deal with that, we should find another point on this parabola. So to find another point, I'm going to find the y-intercept. Right? We don't have to find the y-intercept, but we should find at least one more point so we can graph it with a better idea of the actual shape of it. So to find the y-intercept, we go to our equation, and in the spot of x, we put 0. So we get y equals -1/4 times 16 plus 1. Now looking at this, -1/4 times 16 is -4, and then plus 1 is -3. So we get a y-intercept of -3. So it's going through our y-axis here at -3. Right, so that there is -3. And because this is a parabola, we know it's symmetrical. Therefore, if we go across from that, we can go 4 to the other side of our axis of symmetry at that same height. We have another point, and now we can sketch what our parabola here looks like. Right, and it's symmetrical, so we try and make it same shape on both sides. And then just to finish that off, right, we should put our equation onto there. Right, that's a good habit to get into, putting our equation on our graph. So it's on there now, it's labeled. Okay, another way we could have done the shape, but it's a little bit tricky, is by using our a value. So our a value again was -1/4. So what that tells us is for the first box sideways, basically it's going to go down 1/4. So if you look at this here, right, this here has gone down 1/4, and this way it's gone down 1/4. That only holds though for the first one, and then it becomes a little bit more difficult because it's a quadratic, so it's not linear. It doesn't go down 1/4, then down another quarter, down another quarter. But it's going to go down 1/4, and then it's going to change because it's quadratic. It's not a straight line. Okay, so I would recommend not to do that. Instead, right, find your y-intercept and then use symmetry. Okay, just one more thing here. Looking at this, the question asked for the domain and range. So we want to state our domain and range here. Right, so our domain, right, are the x values that this parabola exists on. So if we look here, right, well, this parabola, right, is there anywhere it's not going to exist? Well, no, it's going to extend all the way across there. Right, so the domain is just x, oh, whoops. X is an element of the real numbers, basically meaning there is going to be some parabola everywhere anywhere. We could say, okay, x is negative 1,000,000. Well, there is going to be parabola there. X is positive 300,000. There will be parabola there. So the x is an element of any of all the reals. The range, well, the range isn't quite that, because if we look, say, up here, right, do we have any parabola up there? If I say, okay, what's the x value when y is 4? Well, that doesn't exist. So basically, the range for this, right, is anything below the vertex, so it's y is less than or equal to 1, but y is still an element of the reals, right, so we should state that as well, right, because it does contain all our fractions and decimals and so forth. Okay, so that is the overall question here. We've answered everything we needed to. We stated our vertex, our axis of symmetry. We set our domain and range. We sketched the graph. We've got it all. Okay, thanks for watching.